Hello and welcome to Code and Magic channel. In this video, we're going to talk about variables and operators. In C# language and any other programming language, a variable, it's like a container that you can hold a value into it. So this container has a data type, which means what kind of data you can hold into it. And also it has a name. For example, in C# for holding an integer variable, we use the int keyword. And we can use a name for this variable, imagine like x, and I can hold a value into it. So here I have a variable called x. Its data type is integer, which means it can only hold integer values. It cannot hold floating point numbers. And the value which is contained in this variable is 100. And here we have a equal operator, which means whatever is inside the right side of the operator, the right side will be put in the left side. So basically 100 will be copied to x. I can have other variables as well, like int y. I can just define it like this, and I can, in the next line, add a value to this line, for example, 200. This is the two ways that I can define variables. Like immediately I can assign a variable, or I can separately define it and then I can assign another value to it. I can do some basic mathematic operations for this variable. For example, addition, subtraction, multiplication, and division. I can have something like int results equals to y divided by x. This is the division operator, and I can use it to divide this value by this one. If I run the application, I can see the result here, which is 2. I can use other operations, for example, plus or minus or multiplication, and I can use all those operators. And the thing is, for multiplication, for division, we should be careful to not divide by 0. Because if we divide by 0, our application will contain an error and will be throw an exception, and it's not run successfully. So if I run it, you see that it says unhandled exception. System.divide by 0 exception. You attempted to divide by 0. This means that your computer cannot do this division, and your program from this point will be break. So you have to make sure you're not dividing by 0. So this is the basic operations. You can also imagine that this is your results and you wanted to print something into output. You can add a string to this result. For example, you can say this is a string before this result, and I can concat this string with this result. And I can say my result is this one. So basically you can concat variables to a string for your output or for some other reasons. And these are the integer and basic mathematic operators. The next one is floating points. For example, imagine I put it back to 200 and I want to delete this. In C# we can also have floating point data types because we cannot use floating points for integers. For example, the default floating point data type in C# is double. And if we define a double, we can hold a number like 1.5. This is a double. There is another data type which is float, and another one which is decimal. We will see the differences. Like imagine if I have a double like this and I have a int like this, I can have a result like double result equals to d multiplied by I. So if I run the application here, I see the result of this multiplication, I by d. I can also rename it to double results. There is another data type for floating points called floats. And if I put f for its name, I can have like 1.25. And the difference is I have to put f after my value to define it as a float, because the default behavior of the value of floating points is double. The default data type is double. So as you see, if I put my mouse over this value, it says it's a double. But if I put my mouse over this value, it says it's a single, which is the .NET data type for floating points. So this is because I have an f. So if I don't have an f, it basically tries to put a double into an f, which is not possible. So I have to put an f here. I can also have float result to f times to I to see the, for example, float result. So when I run the application, I can see the difference. To make sure that I'm seeing something valuable and I can see the floating points, I can use division. So here I can maybe use I divided by D, or I, which is a bigger number, divided by F. Okay. And I would like to have something like this to have a number here. Okay, so you see the difference. This one has a bigger precision and this one has a less precision. There is another floating point data type called decimal. And if I press D for its name, I can have a value like 2.333. And I have to put an M. I have to put M after the value to make this value as a decimal. I can put M also for its name because I have a D here. Decimal results equals to I divided by M. Decimal results. If I run the application, you see the difference between different division results. As you see, this one was double, this one was float, and this one was decimal. As you see, decimal has a very big precision, has a very good precision actually. Double has more precision than float. So if you need a very good precision, you should use decimal. If you need more precision than float, you can use double, but for most of the times, float is good enough. But if you're creating an application that works with money and it's a financial application, for those cases that you're using and dealing with money, your variable for those cases should use decimal because it has more precision. And if I come here to see the floating point numeric types in Microsoft Documents, I can see float, double, and decimal data types and their approximate range, also their precision and size. So the precision for float is 6 to 9 digits, for double is 15 to 17, and for decimal is between 28, 29, almost 30. And their size is different. So float is just only 4 bytes, double is 8 bytes, and decimal is 16 bytes. So make sure what is your system limitation and what you need for your application. So these are the numeric types. The next thing that we need is basically other data types called, for example, instead of numeric types, we have other stuff like string, character, and Boolean values. For holding a string value, we can have a string data type, and we can have a name for it like message and hello world, for example. And we can have for string, you see that we use double quotation, and it contains a list of characters. We have another data type called char or char, and it can hold only one character, and we have to use single quotation to hold the value for it. For example, it can have the value m, big or small m. or A or something similar. We have another data type called bool. This one can hold Boolean values, which is true or false. So basically in computer science, it's basically 0 or 1. So here we translate it to true or false. So maybe it can have something like this. So these are our other variables that you can use. And as you can see, you can also concat your variables with a string. For example, the result is B. So if I run this application, you see the result is true. Or similar for message or characters. So these are the different data types and variables that we can use in C#. Also, you learned about division and multiplication and subtraction and addition. And the other thing is, for operators, you can use a shortcut. For example, imagine that you have your x value is 100, and I can have, for example, another value instead of x, like z equals to 300. And I can do something like this, z equals to z plus 10. But there's a shortcut that is do the same thing, but with less code. Equals to plus equal 110. So basically it means whatever z is, add 10 to it. It's the same as this one. So I can use this operator also for multiplication, subtraction, division, or addition. So also, if I want to just add one value to the last value of z, I can do something like this, z plus plus. There is a difference between z plus plus and plus plus z. Basically, both these operators, plus plus operators, do the same thing, but with only one small difference. And that one is, if I do this, like imagine I want to delete this ones and I just want to have this, and I just want to print this, like I want to have z plus plus. And I want to add a string before it to make sure we can identify it in our output. Z equals to z plus plus. If I print this, you imagine that this should be 300 at 1, but if you see the result, you see that it's still 300. This is because the plus plus operator, the postfix plus plus operator first, like execute the line, and then in the next line, it will execute the plus plus operator. So for this one, it's first the previous value, which is 300, and then in the next line, it will increase the value. So if I print z again, I could see in the next line, it becomes 301. And the difference between postfix plus plus is that the post and the prefix will increase the value immediately in this line. As you see, z is 301 in this line. Well, we have used int to store integer values, but using int is not the only way to store numeric types in C#. In C#, we have a list of numeric types, which contains like byte, byte, short, ushort, int, uint, long, ulong, and etc. If you search for integral numeric types in C#, you will see the Microsoft document for it. The difference is between the range and the size of the different data types. For example, here sbyte means signed byte, which basically signed means having negative and positive values, as you see here, minus 128 to 127. And byte is between 0 and 255. So the range increases and also the size increases. So you have to always consider your system limitation, your hardware limitation, and also your program needs to decide which type to use. But most of the time, integer works well, but sometimes maybe you're using on a specific hardware that you need to store your values in a a specific variable that gets like much smaller size, for example, bytes. For example, if your value is going to contain the age of a person, maybe you should use bytes because it's always positive and it's not more than 255. Or maybe for some reason you wanted to use short. So you have to decide which integer type, numeric type you want to use. For some reason, maybe you want to use long, and which contains a very long value. Maybe sometimes in database ID, because sometimes in databases you want to store more than this value records in your database, so you go for the long. But most of the time it is enough. So always consider what you're using and what is your hardware limitation. Well, so instead of int, for example, you can use long L equals to something. And by using an L at the end of it, you can specify it as long. Well, that's it. Thank you for watching. If you like this video, don't forget to hit the like and subscribe button. See you in the next one.